Hello everyone, welcome to the most common mistakes to avoid in IGCSE physics video. So what I've done in this video is I've compiled more or less all the common mistakes that students make, not just my students, students all around the world. And what I've also compiled is, check this out, a frequently asked question and answer compilation of all the important concepts of IGCSE physics. This is going to be immensely useful. The download link is given in the description below. And I would also highly recommend you watch two other videos. One would be the IGCSE Physics Paper 1 Last Minute Revision, and I would recommend you to watch this before your Paper 1 exam. And the next one would be the IGCSE Physics Paper 2 Last Minute Revision before your Paper 2 exams. Now let's get to work. So the first unit would be from forces and motion. Let's see. So the question says, diagram 1 shows the tennis ball at the instant it is released. The question says, on diagram 1, draw a labeled arrow to show the forces acting on the tennis ball at the instant it is released. So the only force acting on it is the weight, right? And this student has written gravity instead of weight. This is a very common mistake. Now let's see. This was a 2-mark question. However, this response scored only 1 mark. The line of action of the downward arrow passes through the center of gravity of the ball. So this is where they get the 1 mark. However, gravity is not acceptable as the name of this force. The name of the force is weight. You can never write gravity instead of weight. Okay, let's look at the next one. The puck travels at a constant speed of 2.8 meter per second. Calculate the distance moved by the puck. So we all know it's a very clear case of substitution. Speed equals distance by time. And this student has made a substitution error, right? So distance should be speed multiplied by time. What they have done is divided by time. So this is a very common mistake. This response scored only 1 mark because the incorrect rearrangement. Okay, so you have to be very careful while rearranging the values in your equation. The next one, the diagram 2 shows a puck traveling across some rough ice. The rough ice exerts a frictional force on the puck. Draw a labeled arrow on the diagram to show the force of friction acting on the puck. This was just a 1-mark question. But unfortunately, this student scored 0 marks as it is not clear that the force of friction is acting to the left. They have just marked that a force of friction is acting, but this was supposed to show where friction acts, in which direction. We all know friction always acts in the opposite direction to the motion. So the direction of motion is to the right, so friction has to be to the left. You cannot just show where friction is acting. You have to show the direction in which friction is acting. Explain how the force of friction changes the velocity of the puck. So one student wrote, the friction helps the puck to slow down by having a rough surface. This response only got 1 mark. The first marking point has been clearly met, but the explanation given is insufficient. So what do you write as an explanation? This is where the second student has given a very proper explanation. Let's see. Explain how the force of friction changes the velocity of the puck. The force of friction decreases the velocity, which causes the puck to slow down. This is because friction travels in the opposite, not travels. So this was ignored. Friction doesn't travel. The word they should have used was friction acts in the opposite direction in which the puck is traveling. So this was a very clear indication of the student's knowledge that if a force acts in the opposite direction, basically if a resultant force acts in the opposite direction of the motion, the body always decelerates. So this response scored 2 marks. The candidate clearly recognizes that it is due to friction acting in the opposite direction. I repeat, so the opposite direction was a very important aspect of this question. Next. What is meant by principle of movement? Movement before turning equals movement after turning. This student has clearly messed up and mixed up moment with momentum. So for momentum, principle of conservation of momentum or law of conservation of momentum states that total momentum before collision equals to total momentum after collision. So when you're dealing with principle of moments, there is nothing called before turning and after turning. The answer should have been total clockwise moment equals to total anti-clockwise moment. So from here, you can see why you should never mix up moment with momentum. These are two completely different concepts. Next up, this is a question from Forces and Shape. This was a 3-mark question, but this response was also awarded 2 marks for the axis labels and the line starting at the origin. This time, the candidate has marked the start of the curvature as elastic limit. Okay, so this is a mistake. The point up to which the material obeys Hooke's law is called proportionality limit, not elastic limit. So this point up to which the line is a straight line, the graph is a straight line, is actually called limit of proportionality. It is not called elastic limit. Now we move on to electricity. The student investigates how the current in a filament lamp changes when the voltage across the lamp is varied. So guys, I have a suggestion for you. Since your exams are knocking at the door, I want you all to read a question and then very clearly identify, mark, and highlight the keyword in the question. So in this question, you have to vary the voltage. And the question asks, draw a circuit diagram the student could use in their investigation. So you see, if you use a circuit diagram like this, you'll only have a constant voltage and a constant current. There is absolutely no way you get to vary this voltage. So to vary this, you have to use a variable resistor. So this was missing. This response shows the typical response that scored 3 marks exactly. The circuit diagram allows a reading of voltage and currents to be made from the lamp, but offers no way of varying the current to obtain a set of readings or results shown in the question. So the missing component was a variable resistor. So the moment you see varied term in your question, always remember you have to include a variable resistor. Next one, explain in terms of movement of charge particles how the ball has become positively charged. Okay. So the student has written positively charged particles flow to the end of the string and into the ball, making it positively charged. So this clearly shows student does not know the concept of static charge. Positive charges never flow in any setting. Due to friction, there is always a transfer of electrons. So only the negative charges flow from one body to the other. Positive charges lie deep within the nucleus. They are not allowed to flow. So the idea of movement of positive charge to make the ball positively charged is wrong. And so as dictated by the marking scheme, no marks at all can be awarded, regardless of any other credit-worthy content. So if you get confused with the most basic of concepts, you will be heavily penalized. So always remember, in static electricity, it is always the flow of electrons, not the flow of protons or positive charges. Positive charges do not flow. The bar chart shows the results of the student's investigation. Justify the use of a bar chart to represent the student's results. Okay. So why do we use a bar chart? A large proportion of candidates successfully describe the material as a categoric variable. Exactly. So when you have a categoric variable as opposed to a continuous variable, right? So you always use a bar chart or one of the acceptable alternatives. So any guesses, guys, what is the alternative of categoric? In fact, this is a relatively new term. If you look at the recent mark schemes, they'll allow discrete or discontinuous, right? But in the most recent mark schemes, I will highly recommend you stick to categoric. Some candidates hold the misconception that only difference between a bar chart and a scatter or line graph is the ease of representation. Absolutely not. Always remember, you use a bar chart when you have a categoric variable, as in a discontinuous variable, as in when there are no values in between two data. So let's say you have ebonite, you have glass, you have nothing between ebonite and glass. These are discrete, discontinuous, and categoric variables. So the language should have been the rod material is a categoric variable for 1 mark. Next. The dust created by producing flour in a flour mill is dangerous because the dust is flammable. This creates a risk of explosion. Explain why. Connecting the metal channel to the earth reduces the risk of an explosion in a flour mill. Connecting metal channels to the earth. Basically, you are earthing, you are grounding it, okay, by a earth wire. If the metal is earthed, okay, this student got this part right. The electrons from the flour will flow into the ground through the metal and into the ground. This reduces the static electricity present in the flour and lowers chance of explosion. Unfortunately, this response also scored 1 mark. This candidate has attempted to explain why the risk of explosion is reduced, but has just reiterated much of the information from the question. So always remember, repeating parts of the question will never get you any marks. The specific hazard of a spark is not included in the response. Any guesses, guys? What is the hazard of a spark? A spark can cause an explosion. It can cause a fire, which can lead to, it can cause a fire. Okay. Next. A large voltage causes electrons to accelerate from the negative electrode towards the positive electrode. An electron gains 1.0 times 10 to the power minus 16 joule of energy when it is accelerated between the electrodes. Show that the voltage between the electrodes is about 600 volt. The candidate scored 2 marks. Okay, so always remember when you are dealing with charge, voltage, and energy, the equation is always E. Energy equals to QV. So I have charge, I have voltage. No, I have to find out the voltage, and the energy is also given. So E is given, Q is given, I have to find out V. This candidate scored 2 marks. The value of 600 volt is given in the question. So the expectation is to evaluate to more significant figures. So always remember, this is a show that question. This is mandated by the board, everybody. Please listen to me very carefully. That whenever you come across a show that question, always give one significant figure higher than the show that value. So everything was fine until they just rounded it off to the show that value. You can never repeat the show that value in your answer. If it's a show that question, always make sure you give the value to one significant figure higher than the show that value. Next. The student observes that the voltmeter reading increases as the temperature of the room increases. Okay. This is a very common question. When the temperature increases, the resistance of the thermistor decreases. This part is fine, allowing for a higher voltage to go through the voltmeter. All messed up here. Less resistance from the thermistor allows more voltage to the voltmeter, thus increasing the reading. The student has clearly mixed up voltage and current. Resistance affects current, not voltage. It does, but you cannot say passes more voltage when it comes to changing the resistance. That's just not how it works. Resistance directly affects the current. This response scored 1 mark. The candidate correctly stated that the resistance of the thermistor will decrease, but fails to make any link to why this will lead to a higher voltage, higher voltmeter reading. So let me show you how. So the question says, as the temperature of the room increases, check this out. So as the temperature, let me write it down over here. As the temperature increases, the resistance of the thermistor decreases. like I just said, always link change in resistance with the current. If the resistance of the thermistor decreases, the current increases. And since it's a series circuit, the same current flows through the thermistor as well as the resistor. So if a larger current flows through this resistor according to V equals to IR, the resistance is fixed. That's fine. The fixed resistor has a fixed resistance, but if it has a higher current flowing through it, the voltage across it should also increase, in turn increasing the voltmeter reading. Next one, the circuit in diagram 1 is modified by adding a second identical component in series with the other components. Okay, so the next question says, the circuit in diagram 1 is modified by adding a second identical component, check this out, in series with the other component. The temperature of the first component X and the second component X are reduced. Okay, explain how the resistance of the circuit is affected by these changes. So there are four concepts to be addressed, 4 points to be addressed. One is when you add another component in series, the total resistance increases. Also, you have to address the temperature aspect. If the temperature is reduced, what happens to the resistance? So the student has not addressed any of this. Also, this was the general idea among students for this question. See, a large proportion of candidates express some of the right ideas. There is still a misconception that in series circuits have the same current. That is, the current of circuit doesn't change if you change the circuit. That is not true at all. The factor that controls the current in a circuit for a given voltage from a battery, for example, is the total resistance. Next, let's move on to Unit 3 now, waves. Complete the diagram to show the three wavefronts after the wave has been reflected. All right. So this line shows the direction of reflection, and these lines are called wavefronts. Luckily, it's already given in the question. Now, always remember, wavefronts must always be perpendicular to the direction of motion of the wave. So this response scored only 2 marks. This was a 3-mark question, but this student only got 2 marks. Although the ruler has been used, the wavefronts are clearly not perpendicular. It should be perpendicular. So this is, this should be the wavefronts. Use a ruler to make them perpendicular. Also, the wave spacing should remain the same after reflection. Only the wave spacing, as in the wavelength, changes during refraction. So this is refraction, but in reflection, the wavelength doesn't change. So this was also very important to address. So luckily, the student had kept the spacing equal, so they got the 2nd mark. The only mistake was it was not perpendicular. Next, electromagnetic waves can be useful, but can also be harmful. Give one use and one harmful effect of microwaves. So microwaves can be used for heating up food, that's fine. Can cause skin burns, absolutely not. Microwaves do not cause skin burns. Infrared causes skin burns. Give one use and one harmful effect of gamma rays. Use is gamma waves can be used for medical treatment. Gamma waves might destroy tissue in our body. Medical treatment and destroy tissue, all right? Skin burns here is not accepted. And also in the second part of the question, the medical treatment is too vague, exactly. So the student should have said medical tracing, okay? Or in the treatment of cancer, let's say radiotherapy. This is also acceptable. And gamma waves can destroy tissue. This was just barely acceptable. So guys, let me just give you a glimpse of an excerpt from my fact sheet. So this is what you'll get in the fact sheet. So all of the waves that have uses and harmful effects are organized in this manner. For example, for microwaves, they are used in cooking and satellite communication. If you miss satellite, you might lose 1 mark. And the harmful effect of microwaves is it can cause internal heating of body tissues. So you have to be like extremely cautious about the keywords and key phrases that you deploy in your answer. All of these are covered very carefully and curated in the best possible way in the fact sheet. Go through that very carefully. This will definitely ensure a decent grade. Next. So the moment you see diagrams like this, wavefronts bunching up and wavefronts spreading out at the other end, this has to be a concept of Doppler effect, right? Now, explain how the frequency of the wave arriving at point X compares with the frequency of the dipper moving up and down. Hmm. So the dipper, which is producing the wave, that has a constant frequency. Okay, the frequency at point X is greater than the frequency at which dipper moves up and down. This is because the waves are moving towards or into part X, which causes a shorter distance between the wavefronts, and so the wavelength is reduced. Okay, as the waves are moving at constant velocity, as the wavelength decreases, the frequency will increase according to V equals to F lambda. Yes, wave speed remains constant, so wavefronts bunch up, wavelength decreases, so frequency increases. These are the most common points of Doppler effect. So the highest level response called all 4 marks and shows a comprehensive understanding of, like I said, Doppler effect. Next. An oscilloscope can be used to display a sound. Give the name of the variable that is measured on the x-axis of the oscilloscope screen. Always remember, when you are using an oscilloscope, the y-axis always gives you the voltage and x-axis always, without an exception, gives you the time. The only acceptable answer was time, or its abbreviation T. Time period or time base are not correct variables here. Capital T is the letter given to time period. So capital T is not even acceptable. It has to be short t or small t. Next, let's move on to energy and energy resources, Unit 4. Describe how energy is transferred from the sun's energy stored to the battery's energy store. So the photograph shows a camper with a solar panel on its roof. The solar panel is made from lots of solar cells connected together. All right. The sun's energy is transferred by radiation, and when it hits the solar cells, energy is transferred to the battery's chemical energy store electrically. The candidate scored all 3 marks in a different way by firstly saying the energy is transferred by radiation. That's fine. After this, they focused on the battery. They referred to the chemical store of the battery, which happens electrically, right? So in Unit 4, you have to have a very clear understanding and know the distinction between energy stores and energy transfers. There are several energy stores, but energy can be transferred only by 4 ways. They are mechanically, by heating, electrically, or by radiation. These are the only 4 ways in which energy can be transferred. So you have to have a very clear understanding of the difference between energy stores and energy transfers. Next, at high tide, water is trapped behind the tidal barrier. At low tide, the trapped water is released to the turbine shaft. This causes turbine to spin, which generates electricity. Fine. Give 2 advantages of generating electricity using tidal power. One is it is renewable, and the second one, it is not very expensive. So this used to be, I am pretty sure the student had read some previous mark schemes where cost, referring to the cost of construction, was awarded marks. But in recent mark schemes, examiners do not really recommend you write about the cost of construction or cost of production. This response scored only 1 mark for the first suggestion. Candidates should avoid referring to cost-related factors when describing advantages and disadvantages of methods of generating electricity, since these are rarely given any credit in recent mark schemes. They used to be given credit in the old mark schemes. So mark schemes keep on changing from year to year. Explain why a drink in the cup will stay hot for a long when the lid is placed on the cup. So now we have moved on to the methods of heat transfer. By putting the lid on the cup, heat won't escape, very vague, from the cup by uh, convection and keeps the drink stay hot for a longer time. This response scored 1 marks for reference to the lid reducing convection. The second mark was for the lid traps air. So whenever you're using a lid and whenever you talk about, let's say, wool, so how is wool a very good at keeping you warm? Because it traps lots of air, which reduces heat loss through convection. That's why you use woolen sweaters. Now we move on to Unit 5, as in solid, liquids, and gases. A student plays a game using a single dice. The student decides to determine the density of the dice by measuring its mass and volume. Describe how the student could accurately measure the mass of the dice. So this was one of the most common points where students all around the world messed up. Use an electronic balance to measure the mass of 5 dice and take an average or divide by the number of dice. Okay, that's not what the paper was asking you. The question asked, how exactly do you use the electronic balance? So many people did not know that the moment you place or before you place an object on an electronic balance, you should always zero it before placing the object. So the electronic balance should be zeroed before taking readings. So this was missing in almost all the exam scripts. Calculate the density of the patella. Give your answer to two significant figures. This response gained 3 marks. Everything was fine. The final answer had not been rounded correctly. So when a question asks you to give your answer to two significant figures, you cannot violate this instruction. You have to give your answer to two significant figures. But the student unfortunately had given the answer to 4 SF, which got him penalized. Explain how the gas pressure changes if the temperature of the gas increases. You should use ideas about particles in your answer. One of the most common questions. One of the most common questions. The gas pressure increases because as the temperature increases, so does the kinetic energy of the particles. There is more kinetic energy, so the particles move more quickly. So the pressure increases because the particles move more and collide together, repeating the same thing over and over and over again. That is not just how it works. This response is typical of a candidate working below grade 7. So this type of answers will only get you grade 7. Like I said, for every specific question, common questions, you have to have the common points memorized. And all of these are very clearly summarized in the fact sheet. Go through that. And for this specific question, so this should be the answer. As temperature increases, always start with kinetic energy of the particles because the question asks you to talk about particles. As the temperature increases, the kinetic energy of the particles increases. Particles collide more frequently, particles collide harder. These are these are all the keywords that you have to put in your answer. Particles collide more frequently, particles collide harder. The force per collision increases and force per unit area gives pressure. So that's how the pressure increases. Explain why the bottle has collapsed. Okay, so this, let me give you the context here. This is where um, an aeroplane, the bottle is inside an aeroplane, and when the aeroplane descends, the air pressure outside increases, but the pressure inside the bottle remains the same. Right? So let's see what the student has answered. The air pressure outside increases, that's fine, as the plane descends. So the outside pressure is more than the inside pressure, which makes it collapse. So this has to get them only 1 mark. Let's see. The candidate was awarded exactly 1 mark for correctly recognizes that the air pressure outside was greater than the air pressure inside. This is not linked to any references to forces. So collapsing is not only due to pressure, collapsing is due to a resultant force. So because the air pressure outside is greater than the air pressure inside, the difference in pressure creates a resultant force inward. So the missing point was there is a resultant force inward causing the bottle to collapse. Next one, explain why the bubble increases in volume as they get nearer to the surface. So always remember, when the depth decreases, it's rising, right? The bubble is rising. As the depth decreases, the pressure also decreases. So pressure equals to H rho G. H stands for the depth, by the way, in this context. As the H, as in the depth decreases, the pressure also decreases. Now let's see. As the distance between the bubble and the water surface increases, the amount of water that is above the bubble will increase, causing more pressure to be exerted on the bubble from all sides, making its volume smaller. As the bubble moves upwards, less pressure will be exerted, just the reverse, by the water, so it will increase in size. Pressure is inversely proportional to the volume. Let's see. This response scored full marks. The candidate has demonstrated a full understanding of the link between depth and pressure and further linked to the volume of the bubbles. So this is Boyle's law as well. Most responses correctly stated that the link between pressure and the depth, though fewer gave full explanations. Some candidates referred to the formula involving density like this one, and height, but did not define height or explain how it is related to the water in the container. So you don't refer to this as the height. In this context, it is always the depth. A few responses wrongly suggested that water density varied throughout the container. No. In a fixed container, the density remains the same. Next. This is very important. Please be very careful with this question. The air in the storage tank starts at a pressure of 410 kilopascal. As the submarine rises, the air in the storage tank increases in temperature from 2.5 degrees Celsius to 18 degrees Celsius. The volume of the storage tank remains constant. Fine. Calculate the pressure of the air in the storage tank at 18. So this is a very clear concept of pressure law. So you can easily recall the equation P1 by T1 equals to P2 by T2. And this is where students mess up. Let's see, only a third of the candidates knew how to convert the temperatures into Kelvin. So in gas laws, this is of course a gas law. Always remember to convert the temperature to Kelvin. This is one of the most common mistakes that students make. They forget to convert the temperature in degrees Celsius to Kelvin. And how exactly do you do that? You add 273 to the temperature in degrees Celsius to convert it to Kelvin. Please remember this. And you see, only a third of the candidates, as in only 30% of the candidates among 100% got this right. 70% of the candidates got it wrong. Make sure you never make this mistake. Let's move on to the next one, magnetism. This question is about magnetic fields. Diagram 1 shows the poles of two strong bar magnets being held close together. There is a uniform. Be very careful about the keywords in the question. There is a uniform magnetic field between the poles of the bar magnets. Complete diagram 1 by drawing a magnetic field lines to show the uniform magnetic field. Okay. Only one mark here for drawing and labeling the two opposite poles. Even the direction is wrong. Field lines always flow from north to south, not south to north. There is the mistake. The other mistake would be field lines must be straight, parallel to each other, and equally spaced. Only two lines can never show that the lines are equally spaced. You have to give at least 3 lines and never draw them with freehand. Always use a ruler. Only one mark here for drawing and labeling the two opposite poles. The poles are not consistent with the direction nor are there enough lines, like I just said, to show that the field is uniform. The lines have to be equally spaced. So that's why you have to give at least 3 lines. The lines are not acceptably horizontal because they are not drawn with a ruler. Always draw field lines with rulers when it comes to uniform magnetic field, of course. So calculate the force exerted on the current carrying rod by the magnet. So here, the question, even though it's from magnetism, but the question has nothing to do with magnetism itself. The candidate scored 3 marks. The calculation is correct, but the lack of converting units of mass from grams to kilograms resulted in a 1 mark penalty. This is again one of the most common mistakes that students make. They forget to convert mass in gram to kilogram because gram is not an SI unit. Kilogram is an SI unit. And you had to draw a line of best fit or a curve of best fit. No marks were awarded here. Candidates should not join the points together when plotting graphs in physics. A single line of best fit should be drawn with equal distribution of points about the line. So this should have been a line of best fit, and the way you draw a line of best fit is there has to be equal number of points above and below the line of best fit. A student takes strong magnet away from the iron block. The student suggests that they can permanently use iron block to attract small pieces of iron. Explain whether the student's suggestion is correct. No, iron cannot be converted into permanent magnet material as it is soft magnetic material. The use of the term soft here was taken to mean soft in the magnetic sense, so 1 mark here, fine. But why did the student not get the second mark? Because you had to say iron loses its magnetism once it's moved away from the magnetic field. Describe the structure of a step-up transformer. Okay, one more thing. There are some topics that you only have in paper 1 and some topics in only paper 2. So transformer questions are only in paper 2. Describe the structure of a step-up transformer. You may draw a diagram to help your answer. Primary coil is coiled around the side of a soft iron core. Core is made up of iron as its soft magnetic material, which is easily magnetized and demagnetized. Secondary coil is coiled around the other side of the iron core. Secondary coil has more turns in the coil than primary coil, making it step-up transformer. Primary coil has an alternating current. Fine. So the reason I gave this question in this video is you have to understand the differences between the structure of a transformer and the working principle of a transformer. I see a lot of times students mixing up these two concepts. They mix up structure with working principle of a transformer. They are not the same things. Again, very clearly explained in the fact sheet. Next. Okay, so I have to talk about this. Step back, sit back, relax, and just delve into the details of this concept. So even though these two setups look identical or very similar, these are completely different concepts. And I see students all around the world messing up and mixing up these two concepts. One is a motor, the other one is a generator. Now, most students mix up these two concepts. Make sure to learn the points and make a clear distinction between motor effect and generator effect. I will highly recommend you go through these two concepts very carefully and you find out where you use the term field lengths interact and where exactly do you use the term field lengths are cut. Okay, so the students mix up these 2 points and at times use them interchangeably, which will definitely get you penalized. These two concepts are reserved for either DC motor or for generator. You cannot use them interchangeably. Now we move on to Unit 7, Nuclear. Give two safety precautions to minimize the risk of harm to the teacher from the radiation emitted by protactinium generator. Okay, wear gloves, wear lead apron. I don't think lead apron will get you the mark. This response scored 1 mark. Lead apron, yeah, like I just said, lead apron was ignored. Don't write lead apron. The next one, let's see. Another student, of course, wrote, minimize the time spent with the radioactive isotope. Use tongs when handling the isotope. Yes, this response got 2 marks. So whenever you are trying to minimize the risks of ionizing radiation, always in the laboratory especially, or in the schools, always write, minimize the time of exposure and handle with tongs. These 2 points almost always get you the marks. Next, protactinium 234M decays with a half-life of 70 seconds. Calculate the expected count rate after 140 seconds. Again, this is one of the most common mistakes that students make in half-life calculations. Today I'll show you a method that is guaranteed to get you to the final and correct answer. And that is using graphs, everybody. So if I just draw a graph, it minimizes the risk of getting it erroneous. Activity against time is in seconds. So the initial activity, by the way, the other name for activity is count rate. So the initial activity or the count rate is 840. This is 840, and you know the decay curve is always like an exponential decay. So the half of 840 is 420. And you already know by now, I'm pretty sure, that the time taken for the activity to half is called the half-life. So half-life is already given here, 70. So the time it takes for the activity to drop down from 840 to 420 is 70. Next, from 420, the time it takes for the activity to drop down to, let's say, 210 is again 70. So already 70 plus 70 gets you 140. And that's exactly what the question asks you. Calculate the expected count rate after 140 seconds. So after 140 seconds, check this out. The count rate is 210, not 420. So this question is not exactly a physics question. This is a mathematical question. And most candidates messed up badly in this question. So let's see. The activity of an isotope is the total amount of radiation emitted each second. Fine. The teacher estimates that only 5% of the total radiation emitted is detected by the radiation detector. Estimate the activity of the isotope when the count rate is 840 counts per second. And guess what? This is the most common incorrect response, where students found out the 5% of 840. No, that's not what the question asked you. The question said only 5% of the total radiation is detected. So this is the detected radiation. So let's say activity, right, of the isotope, only 5% of this activity is detected, and the detected count rate is 840. So this should have been the way. So activity equals to 5% means 0.05. So 840 divided by 0.05, and the value is 16,800, and the unit of activity is becquerel. So this is the activity, and of this activity only 5% is detected, which is 840. So you have to read the question very carefully. Next, the last unit, as in astrophysics. Let's see. The question asks you to draw the orbit of the moon around the Earth. This response only scored 1 out of 2 marks. The shape of the orbit is clear enough to be judged to be a circle. However, the candidate has not taken enough care over their placement of the Earth and is clearly not at the center of the orbit. Always remember, uh, the orbit of the moon around the Earth is circular and Earth should be at the center, but it looks Earth is at one end, which is incorrect. Explain how stars can be classified according to their color. This is again one of the most common incorrectly answered questions. By the temperature, red means it has the highest surface temperature. As you go down, the surface temperature decreases. From the table we know Antares is the hottest and Vega is the coolest. This response scored 1 mark. The candidate has recognized that the color of the star depends on their surface temperature. However, their understanding of which color is hottest or coolest is incorrect. It is a common misconception that red is hot and blue is cold, as we see in television advertisements, right? So when they have to show something cool, they show blue color, and when they have to show something hot, they show a red color, red theme, right? But that's not just how it works in real life. Red is actually cooler when it comes to stars, and blue is actually hotter when it comes to stars. Now, let's look at the secret recipe for success. 1. Go to the fact sheet inside out. Watch the 2 last-minute revision videos, but please make sure uh, there are 2 separate videos. One is for paper 1, one is for paper 2. Watch the paper 1 video before paper 1 exam, watch the paper 2 video for the paper 2 exam, and finally, practice all the recent question papers and definitely make sure to check with the mark scheme. Good luck with your exams, everyone. Take care and thanks for watching.